Hello and welcome. Not a day goes by in which we don't see another company in the headlines due to a data breach. All of us are spending significant amounts of time and money ensuring that we are not tomorrow's story. And this increased focus is leading the bad guys to adapt. A recent data breach study commissioned by Verizon showed that in more than 80% of hacking-related breaches, weak or stolen passwords were used. And traditional perimeter security will not stop a correctly authenticated and authorized user. So what is to be done? We'll be covering the architecture of the solution, how it uses behavioral analytics to see every conversation, to know every host, to learn what is normal, alert you to when there's changes, how it can help monitor policies for segmentation, and how it can give you rapid threat response. So let's talk about Stealthwatch Enterprise and its architecture. So, what is it? Well, in a nutshell, it's a way of taking information from the network, telemetry, and that information comes in from various forms into our network. Now, information on its own without any context has no meaning. So it's very important that we add in context to this. And this context can take various forms. We might want to know, what is this? So some idea of the classification of this device. Is it a DNS server? Is it a host? Is it a SQL server, etc.? We might want to know something around who's on the device, who is the user. And we also might want to know some idea of what's happening in other locations. So what do we know from our intelligence sources? Have we seen this kind of behavior before? So we add this all in to a data model. And that is a way of adding all this data together to make sense of it in a way that we can then actually run analytics on top. Because really, what is our goal here? Our goal is to take outcomes, actionable outcomes. And Stealthwatch is all about this. How do we take telemetry from the network, give it meaning, and then run a form of analytics on it to give you an outcome? So let's talk about the architecture of Stealthwatch Enterprise. Simply, it's three main components. The first is what we call the exporters. This is our way of getting this transactional telemetry into our data model. Now, this can take the form of NetFlow or IPFix coming from the network. It can take the form of using some of our products, the UDP director, which is our way of forwarding on UDP streams or replicating them. It can take the form of the flow sensor, which is our device to be attached to a span port for those that can't speak native IPFix or NetFlow. And that really allows us to take that span port information and convert it into the telemetry that we need in our data model. It also takes the form of the endpoint. For those users who are not on-premise, who are on the AnyConnect VPN client, we have the ability to export information from those. And all of that information comes together and is included in our data collection layer. And our data collection layer is the flow collector product that really brings all this information together and puts it in this data model we talked about earlier. So there's a lot of things we have to think about as we get large amounts of telemetry and transactional information in. How do we deduplicate all of the information that's repeated? How do we stitch this together into a meaningful conversation so that we can understand who is talking to who, about what, for how long, etc.? And in some cases, we might want to go even further and bring up more forensic tools to bear on the actual packet stream. So we have another product called the Packet Analyzer. And the Packet Analyzer is a rolling packet capture buffer that allows us to actually capture packet for packet the conversation that's going on. Now, all of this is then fed into our analytics layer. And at the heart of the analytics is the Stealthwatch Management Console. And that's our tool for doing all of the entity modeling and machine learning with enhancements from the cloud that we talked about earlier. And that's really the brain of the Stealthwatch architecture, and it's where we pull in all of our threat intelligence from around the world, what other bad guys are doing, what other customers are seeing, what are other Cisco products learning about. And it's really enhances this data model that we've built here at the collection layer to give us these key actionable outcomes that we all need. So in this section, we'll be talking about Stealthwatch Enterprise and how it uses entity modeling and machine learning to detect threats both in normal and encrypted traffic. So as we said earlier, we've collected a comprehensive data set from all our data exporters and from all the various telemetry sources on our network. Now we really need to convert this into events. So how do we do this? Well, we have more than 100 heuristics that run on our data set to convert it into meaningful events in the network. For example, these might be known bad behaviors, such as reconnaissance. So as we model this out, we understand if a host or an endpoint on the network is busy sending out a lot of traffic to identify other vulnerable hosts or weaknesses. Or it may be something more subtle. Leveraging a behavioral model in our entity modeling, we can understand if the behavior of the endpoint has changed. So in other words, if you suddenly start downloading a lot of information from the servers and storing it on your machine, this is a more subtle form of data hoarding that Stealthwatch is able to see and identify as an event of interest. And then ultimately, we want to turn these events into our endpoint, which is alarms. And that's really taking these thousands of data points that we had and converting it into the 0.01% of key information that you need to understand, either via the alarm console or the SIEM or email, depending on what your workflow is, to really allow you to identify and respond to all these events that you're seeing. Now, for the case of encrypted traffic, how can we identify what's within? Well, really, there's three key components that we have in encrypted traffic analytics. The first is what we call the initial data packet, or IDP. This is the very first packet in a conversation that's exchanged. And because all encrypted conversations need to start in an unencrypted way, all this information, by its very nature, is unencrypted. We want to maximize the use of all these unencrypted fields by capturing that initial data packet and sending it off for analysts. We then look at the overall conversation that's happening, the traffic analytics or conversation analytics. How are we talking? And we call that the split. And then thirdly, we want to add in what do we know about who's talking. So this is the idea of threat intelligence. If you're talking to somebody on the internet that's already been identified, either through industry analysis or another Cisco security product, as a potential bad actor, then we want to add that information into everything else we knew. And that allows us to really identify malware that might be inside an encrypted traffic stream. So how might this split, or how might this look? Well, if we have two people talking, their normal conversation, if this was a client-server relationship, might look like this. But if we had malware speaking, the conversation pattern would look very different. And leveraging machine learning to understand the pattern of communication is what allows Stealthwatch, in addition to all the entity modeling it's done here to understand the behavior and what is normal, to really identify if that is a malware family inside that encrypted traffic stream. In addition, since we're capturing all this information and all this data, we're able to audit for cryptographic compliance in an extremely simple, easy, one-button report. Rather than having to go and manually audit every host and every application to ensure, for example, that it is using a TLS 1.2 connection rather than the less secure TLS 1.0. So let's talk about smart segmentation. Since Stealthwatch sees everything that passes over our network, and it has the context to understand what everything is, it is very easy to overlay the policies into Stealthwatch so that it understands how things should be talking. From there, we can either model or monitor any policies. So what would that look like? Let's take the example of a PCI network. We have our employees. And our employees should be allowed to talk to the internet. Now, from a production server perspective, they should be allowed to talk to production services, but in a more restricted fashion. Because there will be a policy about what production servers they should be allowed to talk to and how they should talk. In the case of payment servers, though, there should not be any communication allowed. And that should be a policy. And while we may deploy traditional enforcement techniques to ensure this never happens, one of the challenges with them has always been that while they're exceptionally good at reporting what they've blocked, they really don't tell you what passed through. So it is hard to know actually whether your policies are working in the way that you thought they were. So by deploying Stealthwatch and understanding and modeling the policies and then looking at the actual conversations that occur, we're able to understand whether, for example, employees are ever talking to the payment servers or whether they're talking to production in outside of what would be considered the normal policy, the restricted policy that we put in place. In other words, whether your firewalls are working in the way you think they are. And it is possible to build more subtle or granular policies and model them. For example, our production servers may be allowed to talk to the internet or vice versa, but that might say that you can only use HTTPS, so an encrypted traffic stream, and HTTP would be banned. Today, that would be very easy in Stealthwatch to model and understand and ensure that you know it. This is both for the perspective of enforcing or monitoring your policies that exist today, but also when you're considering a future segmentation. How would I change my policies to change the way people or endpoints or servers are able to communicate? Using Stealthwatch, you can actually build these policies in and ensure that they work and that your network works in the way you think it does before you go ahead and configure those firewalls. So let's now talk about threat response and how Stealthwatch Enterprise allows you to pinpoint the source of a threat, conduct forensic investigation, and mitigate that threat with minimal business impact. So really there's two key components. The first is investigation. So Stealthwatch provides several tools to help you with your investigation. Since we have this huge data set of what's been occurring on the network, we understand the contextual information regarding a host, user, or application. In addition, we give you a prioritized list of top alarms that allow you to deal with the most important thing first. And since we have all that information as security events, we allow you to drill down and get into more of the detail of what those mean. In addition, Stealthwatch stores this information over a prolonged period of time. So this allows you to delve back through the audit trail and conduct a forensic investigation to understand how this malware has propagated in your network, who it's been talking to, and how it's spread. Once you understand the nature of the threat, you're then in a position to respond. So this really depends on your workflow. And Stealthwatch is very flexible about how it integrates. Whether it's something as simple as an email out to people, if it's a critical alarm, or if it's something like integration into your SIEM or syslog, or even an alert on the Stealthwatch management console's dashboard. Stealthwatch has several options to allow you to integrate this with your operations team. Finally, Stealthwatch has various integrations and options with existing Cisco products. If you've invested in the Cisco Identity Services Engine, or ICE, you have other options around rapid threat containment and how you can quarantine a user by having Stealthwatch notify ICE to change the policy. This enables you to set a new policy that actually prevents a host or endpoint accessing critical business services. I want to take some time just to address some common questions about Stealthwatch Enterprise. Firstly, is Stealthwatch ready for virtualization? The answer is absolutely yes. We offer both physical and virtual versions of all our products so that you can make the decision as to the best deployment model for your environment. Do I need to deploy sensors everywhere? The answer is no. We give you the option of deploying sensors where it makes sense for your deployment in the form of the flow sensor, but we also offer the ability to take streaming network telemetry from your existing network infrastructure in the form of NetFlow or IPFix. What is the overhead associated with turning on streaming telemetry? On average, we see less than 1% network utilization caused by turning on the network telemetry. In today's video, we've learned how Stealthwatch Enterprise can give you visibility everywhere, how it can give you threat detection through machine learning and entity modeling, how it can give you encrypted traffic analytics, how it can give you smart segmentation through policy monitoring, and how it can give you rapid threat containment. All of this value can be accelerated through the use of Cisco services, from support services to advanced services to education services. And Stealthwatch Enterprise is just part of the overall Stealthwatch portfolio that gives you comprehensive security analytics everywhere. For more details about Cisco Stealthwatch, please visit the following link.